Welcome once again. And today I'm going to go ahead and teach you a very important topic that most people avoid, but it's one of those necessary evils. It's a dry topic because you really don't need it unless you are at a high scale designing networks, or you will need it for your exams. So most certification exams, starting from A+ to Network Plus to CCNA, to Firewall, any certification, network certification that you do or you get to, subnetting has several questions. And many students have failed because they can never understand subnetting. So today, you can say subnetting simplified, because it took me back in the days several years to understand subnetting. I went through different books until I finally sat down one day and I killed the beast. And now I think the way that I learned it is the way that I want to train you. Now, the best way to understand what subnetting is that when IP addressing comes into play, we really need to form subnets because it increases security, it increases productivity, and now IP6 is in its place, but IP4 has not left the industry yet. And more than likely, by the time we completely get rid of IP4, it will be a few years. So the questions are still on your exam, so let's begin. So let's start with a scenario first. So let's say, for instance, that you have a company whose network you need to design, and we can call the company Abco Technology. So you have Abco Technology. Now, Abco Technology is telling you that they have 25 locations. So basically, they're going to begin with 25 locations. And in these 25 locations, and they're telling you that in the next 4 years, they are going to probably, or the company plans to double their location. They also say that the amount of devices or nodes on the network, or the network size, is about 500 devices or 500 nodes. For those of you who do not know what nodes are, each device that connects to your network is a node. So these could be 500 people, these could be 500 computers, this could be computers, iPhones, tablets, whatever have you, that are divided. But here's an important point that I want you to say, that when someone says that we are going to design a network for 25 locations and 500 nodes, does that mean that those 500 nodes are going to be at all 25 locations? Or does that mean that those 500 nodes are at just one location? Well, generally, when it talks about subnetting only, it means that those are 500 nodes per location. And in a technical lingo, I would say 500 nodes per subnet. So when we go to assign an IP address, we always type the IP address, and if it's a class, if it's an IP4 subnet, there are 4 octets. I will explain to you in a few minutes why they are considered to be 4 octets, or why they're called an octet. And below that, we write the subnet mask. So now, let's go back to our company. The company said that they're going to start with 25 locations. They're going to have about 500 nodes per location or per subnet. And in the next 4 to 5 years, the company plans to double their size. So to me, what that would mean, that after about 4 to 5 years, this company is going to have 50 locations and about 1,000 nodes per subnet. Now, I will show you here in a quick moment that why subnetting is important. So, before I go there, I need to talk about the classes. So, let's begin again with the understanding that we are going to do subnetting for 50 locations and about 1,000 nodes or 1,000 devices per subnet. So that's our goal. Remember that. Now, here I'm going to take a step back, and we are going to start with understanding that the IP address, the IP4 address, was in binary system, which means that everything was a 1 or a 0. So you had, and wherever there was a 1, it's considered as a bit, and then 0 as no bit. So that's the first thing. The second thing is that the IP4 was a 32-bit address with 4 divisions to it. So how many bits does that give us? It gives us 8 bits altogether, because how many do we have? We have 4. 1, 2, 3, 4. So that's why I was calling it as an octet, because it has 8 bits. Now, moving forward, so basically what I'm going to do here is I'm going to write 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. What I just wrote is 8 bits. So if you were to look at an IP address, it's in binary, and we would have to write 8 ones here, 8 ones here, 8 ones here, 8 ones here, and all together, when we fill up all 4 octets with binary numbers, they would become a 32-bit IP address. Now, I wrote those 8 ones for a reason, because these 8 bits is how the computer understands. But humans don't understand that way. Human understands it in decimal format, Otherwise, if you see a bunch of ones and zeros, how many of you are going to remember what that ones and zeros are? Like if I say 1101, 1011, 1110, how many of you are going to remember? What I just said was 8, 9, and 10. You see that? So basically, in order for you to understand binary numbers, you have to convert it into decimal. So look at this as 8 ones. Now, here is where some books go and show you how to convert a binary number into a decimal number. You don't need to worry about that, because here we're not dealing with any binary numbers. We're only going to deal with 8. So when you have 8 bits or 8 ones, what you're going to do is you're going to start from the very left, which is what you're going to say as the 8th bit or the 7th, because it starts from 0, and binary numbers do go from right to left. So start from the very left, and if we had only 1 bit, the decimal equivalent of that would be 128. If we had 2 bits, so the second one would be half of 128. What's half of 128? 64. So we would have 64. If we had 3 bits, which means at the third position, it's now half of 64, which is 32. If we had the 4th bit gets added, it's half of 32.
16.
It's 16. If you then continue with the half of that, so then that's 8, 4, 2, 1. You see that? Now I've written down all the bits. So the only thing I need to really remember at this point is 128, right? Now, if I come to you and say, so at 5 bits, what would I have? Well, all you have to do is you have to count till 1, 2, 3, 4, 5, and then add from 128 all the way to the position at the 8th bit, at the number 8, because at the 5th bit, the decimal equivalent comes to be 8 from what we've written here. So now, to make it further, to simplify it further so that I don't even have to do a little bit math, what I'll do is I'll say, okay, if it's 1 bit, it's 128, right? But if it's 2 bit, it's 128 plus half of that. So that's 128 plus 64. So if it's 1 bit, it's 128. If it's 2 bits, it's 128 plus 64, which is 192. If it's 3 bits, it's 128 plus 64 plus 32, and that's 224. And then 240, 248, 252, 254, and then finally 255. See, initially you could take a calculator at home and start adding these numbers, and then you say, oh, this is simple now. So now, once you wrote it this way, your job is easy. Because if I tell you I want 5 bits, all you need to say is, 1, 2, 3, 4, 5. And instead of adding it there on the exam, I'm writing, after 5 bits, my total is 248. So that's my number. If I say, well, what about 7 bits? Okay. 1, 2, 3, 4, 5, 6, 7. After 7, it's 254. If I say, what about 3 bits? Oh, sure. 1, 2, 3, 224. So you can see that in a very simple way, whether you tell me there's 8 bits, 7 bits, 6 bits, 4 bits, in a very simple way, I've been able to write down for you what the decimal equivalent of that is. Did we do any math yet? Basic math that a first grader or second grader or third grader may have known. And that's about it. And that too, we just wrote down all the bits. Now we don't need to do any formula, nothing. All we need to know and ask how many bits are there. See what I mean? And just remember that if the number is beyond 8, you don't need to worry about it. So if I tell you there's 10 bits, it's not literally 10. You would say there's 8 and there's 2. Now, 8, the full 8 is 255. That's why your IP address in decimal format will never go above 255. It will never go 0. So all bits are 0, it'll be 0. All bits are 1, it'll be 255. And an interesting fact or fun tip is, in the movie Net, some of you haven't seen Sandra Bullock, coming from the 90s, they actually showed her to be a computer geek, and she's hacking, and she types an IP address which is 304.354. something like that. And I was standing there sitting laughing because I was thinking that an IP address, so they totally faked it, but it looked really good in the movie, the way they did it. But they showed the IP address to be 304 and 355 and 362, but you know now that an IP address cannot go over 255. If you haven't seen the movie, by the way, it's a movie from the 90s. It's great. It's called The Net. Anyway, so we move on and we go back to our simple company that has how many locations?
25.
Yes, but we're doubled it, so it became 50. And how many nodes per network? 1,000. Okay, so we had 50 subnets and 1,000 nodes per subnet. Just remember that. 50 subnets, 1,000 nodes per subnet. Now, there are 3 classes in which IP address was split. The reason it was split was because we wanted to make sure that more and more classes or more and more networks can be formed. So the first one is class A. The second one is class B. The third one is class C. Then there's class D and E also, but I'm not going to cover that right now because only these three are used to assign the network to the network. So you know how we have a first name and a last name? So if my first name is Arif and my last name is Syed, when I'm outside, people will call me either Arif Syed or they will call me Mr. Syed, you know. But when I'm at home, my dad is not going to call me Mr. Syed, you know, unless he's mad, you know. But if he's mad, he may. But otherwise, he would generally call me Arif. So inside, inside our family, we always call each other by our first name. Then when we're outside, we have to be referenced with our first name and last name. And just like a family must all have the same last name, not necessarily, but most likely. So similarly, the IP address is also kind of divided into this first name and last name. What do I mean by last name? Okay, so the last name is the network address of the IP address. So there's a network address. Then the first name would be the host address. So let's suppose this is my computer. Now this is my computer, and I need this to be on the network. So I have to assign a host address. But it's going to have a network address too. And if I have, say, another computer that's on the same network, the network address has to be the same. If the network address, that's called the last name. That means we're part of the same family. We can communicate directly. If the network address changes, so two devices, if their network address changes, even if they're physically in the same room, in the same place, connected in the same way, they will not be able to communicate without a router. Okay? So basically, keep this in mind, that if you want all the devices on a subnet must have the same network address and must have a different, unique host address. Two devices, if they have the same network address and the same host address, then there'll be an IP conflict. It's like having two Charles Pascal in the same room. You know, we cannot have that. If one is Charles Pascal, someone else could be another Pascal, so that we can address them with their first names. So that's how the network is formed. So now these classes, people often wonder, what are these classes doing? These classes are defining the network address for the one. So the first thing, we will start with the smallest, which is class C. So class C, it's based on the first number. Now you notice, guys, that IP address was between 0 to 255. So what the Internet Authority of Assigned Numbers, IANA, what they did was, they said, okay, if your first octet has a number between 0 to 126, you belong to class A. If your first octet has a number between 128 to 191, you belong to class B. Now all those of you who are wondering, what happened to 127? Why did we skip 127? Because we went to 126 and then we jumped to 128. Well, there's a reason for that. And I'd like for you to enter it into the comments of why I skipped 127, you know. And you get some brownie points if you answer it correctly. If not, then I'll reply to your comment why 127 was skipped. You can also ask me, I don't know, you know, and then I'll reply. And then class C is from 192 to 224. Okay? And I told you class D is from 224 to 242, and then 243 to 255. But again, class D and class E is not needed because you can only assign to devices IP addresses between A, B, and C. D is used for broadcasting. E is used for testing. So 0 to 126, you're from class A. 128 to 191, you're from class B. 192 to 224, you're from class C. Now you're wondering, okay, Reef, you told me what class A, class B, class C is, but what does that mean? What does that mean to you? Well, what that means to you, that if you belong to class C, the first 3 octets is your network address. And you're only left with the last octet as your host address, okay? So let's assume we're starting a network, and you say, okay, Reef, I'm going to choose class C, okay? Let's pick up a number in the first octave between 192 to 224. I'll say, okay, let's pick up 200, okay? So I'm going to start my IP address with 200, 200, 200, and remember, the last one is for my host. So I'm going to keep it started as 0. Now 0 is header, so you don't assign a header. So the first computer I hook up a computer. The first computer I hook up, I'm going to give it 200, 200, 200, and then 1. So it's going to go with 200, 200, 200, and then 1. Then I hook up a second computer. I give it 200.200.200.2. Then I hook up a third computer. It goes 200.200.200.3. Remember I said, in class C, the first 3 octets is the network address. I also said that the network address cannot change. So what does that mean? That when you are building this network, the network address cannot change, which means the number in the first 3 octets, I arbitrarily picked up 200. You could pick up any one between 192 to 224. The most common one, most of you already know, is 192.168.1, which is used. So you can pick up anything you want. Now, you start going with 0, 1, 2, 3, 4, which means each number you are assigning to a device on your network so that they can communicate, they can access internet, they can send email, they can store files. But what's the maximum number of IP addresses that can go into an octet? What's the maximum number? The maximum number is 255. Because your IP begins from 0 and it goes to 255. So imagine this. You start from 0. The first network that you assign is 1, and then you go 1, 2, 3, 4, 5, 6. When you reach 255, can you move ahead? No, you can't. Why? Because if you move ahead, you'll have to change the network address. Because 200, 200, 200 is static. Now you go 0, 1, 2, 3, 4, 5, 6, 7, 8. These are devices, guys, on your network. You're attaching those devices. And when you reach 255, that's where you got to stop. Now you come to me and tell me, Arif, I'm stuck here. And I'm going to say, wait a minute. How many people were there on your network? How many nodes were there? Now, if the number of nodes in your network was 100 or 150 or 200, and you assign this, that's great, because you're going to be within the range. But if your number was like our company, where we had 1,000, after the 255 is reached, you're going to tell the next guy, oh, I need to purchase a router for you? It's not going to work like that. So you have to move up one more, okay? Class B, they have the first 2 octets as the network address. So now what happens is you start with, say, 172. So I'm going to pick up 172.16, and now these 2 will be 0. Now you see how many IP addresses can go on one network. How many devices can be hooked up on one network. So you see, you start with 172.16.0.0, then .0.1 you assign, 0.2 you assign, 0.3 you assign. You keep going. What happens when you reach 0.255? You can now, like an odometer, increase the next octet to go 1, and then move this one to 255. So basically 1.0, 1.2. So now you have 255 times 255 times 255, 255. You keep adding till both octets, like an odometer. So every time this number in the third octet increases from 0 to 1, the fourth octet resets to 0 again, which means you just got another 255. Then you go from 1 to 2, then you got another 255. This way, you've got 255 times 255. How many devices would that be? That would be 65,536 devices on a single network. I don't think there's a company out there that has so many people working on the same network. But that's the maximum what Class B could offer. Now comes Class A. Let's pick up a number for Class A. I'm going to pick 10. Now in Class A, there's only one octet that has the network address. The rest of them can be assigned to the host. So 10.0.0.0. Now look, you have 3 octets. With just 2 octets available for you for the host, you got 65,000. Now a third got added to it, which means every time this one increases, both reset to 0. And when both of them are 0, by the time they get filled with 255 and 255, you've got 65,000 addresses. So now with each octet, with each number that increases in the third octet, all the way from 0 to 255, you end up with 65,536 times 255, and that's 16 million addresses. So with just one number, with the Class A network, you can get 16 million addresses on a single subnet, in a single company. This company exists. Can any one of you name this company that has 16 million addresses on one subnet? It's called the Internet. The Internet was established on Class A IP address. But we're completing that, which is why we moved to IP6, which is now from a 32-bit has gone up to 128-bit. And of course, we filled the holes of IP4, but still there. That's why I'm still talking about it. So you see, guys, all the way from Class C, where you only have 1 octet and 3 octets as your network address, then 2 octets, and then only 1 octet. So you have 3 fields here, which becomes your network address. You have only 2, and you have only 1. And how does the computer know which one it is? It's through the next field, which is called subnet mask. So what happens is, when you use a Class C address, below the IP address, you'll write 255.255.255.0. So this becomes the IP address, and this becomes the subnet mask. So what happens is, the subnet mask is not for you, the subnet mask is for the computer. By typing 255 below the IP address, you're letting the computer know this 200 is a network address, this is a network address, this is a network address. By typing a 0, you know, in the subnet mask field, you're letting the computer know that this number is the host address, which means the host will get this as this is how the host will be contacted, this is how the host will be communicated. So 1, 2, 3, 4. Now, in a Class C network, you have 2 octets as the subnet mask, as the network address. So what would be our subnet mask now? 255.255.0.0. In a Class A address, we only have 1 octet as the network address. So what will be our subnet mask? 255.0.0.0. So now I am going to go ahead, and I know I wrote a bunch of numbers that some of you may be confused at this point. So I'm going to erase this and write it in a more lucid manner, and so that we can fully understand. So once again, guys, let me repeat this part, that there are three classes of addresses that you can assign to hosts. You have class A, class B, and class C. Class A, class B, and class C. Class A, the first octet must have any number between 0 to 126. Class A means that the first octet of the IP address is network address. The remaining are all assigned to host. So let's begin with 10.0.0.0, and the subnet mask would be 255.0.0.0. This means that the first octet is the network address, and these all will go to the host. At this rate, you can get 16 million nodes on one network. Now, class B is a number between 128 to 191 in the first octet, and it has two octets as your. It has two octets which are your network address. So you have 255.255.0.0. Your address would be something like 172.16.0.0. You would begin with 1, 2, 3, 4 and reset after every time this increases. This would allow 65,536 addresses that you can have on a single network. And then the most commonly used class C is the one that you are going to use, which is from 192 to 224. And this one has the three octets as the network address. So you would have something like 192.168.1.0, and all three is network, so 255.255.0. The first three octets are the network address, so you're only left with one octet left, and you will end up with only 256 addresses on this network. So if you have a small company with less than 256 addresses, you will use the class C. This is the end of part 1. We will begin subnetting in part 2.